Now, welcome back to solving one more good numerical from engineering mechanics. Problem set 2.5, solution to 2.78. As you can see from the original diagram, a bar AB is a bar, it is hinged at A. A bar AB hangs to the foundation at A. Here is a foundation, it is fixed at A and supported by a strut CD. I will explain you what is a strut. This is supported by this strut channel CD, is subjected to a horizontal 50 kilonewton load. From this end, a 50 kilonewton load is applied horizontally to the right hand side at B as shown in figure. This is your figure M. Find graphically the tensile force S in the strut and the reaction at RA at point A. So don't initially think that the reaction force at this point of contact will be to this side. Let us find out the conditions for equilibrium. We studied in previous lessons when there are three forces lying in a plane pointing in different directions. To be in equilibrium, they should have a point of concurrence and they should form a closed triangle taken in order. Or you can say the resultant of any two must be equal in magnitude and in opposite in direction to the third one, so that the condition of equilibrium will be established. So let us begin. CD part, this part is a strut. So initially the weight of the bar is not mentioned, so we shall not consider, but we'll find it out at the end of the problem. Now what is a strut? A strut channel. A strut or a strut channel is used to mount or brace or support and connect lightweight loads. For example, this strut bar CD is connected to the bar AB and it is carrying its load. So this bar AB is trying to compress this strut like this to this side. So there will be a longitudinal compression along the CD. There will be a longitudinal compression. So what it does, it provides outward facing support. Means this strut bar CD is providing a outward support in holding this bar in this position when 50 kilonewton force is applied horizontally at point B towards the right. So it provides outward facing support in their lengthwise direction. This is the lengthwise direction. In the lengthwise direction, it is providing support to this bar AB. Now, let S is equal to the tensile force developed in the strut CD acting. So it will be acting away from the point C to this side. Let it be S. And the diagram I will redraw again for better understanding. Let E is the midpoint, is the point where the line of action of the 50 kilonewton and axial forces meet. Means if you extend the line of action, this axial forces to this side, and the line of action of the 50 kilonewton force, they meet at this point. So let that point is equal to E. I will be drawing a different diagram to explain it better. So what is the conclusion? There are three forces. This 50 kilonewton, this axial force S, and from here there will be reaction force. So the reaction force has to pass through the same point E. The reaction from here has to pass through the same point E. or A. So the reaction from the point A must pass through the same point E. Now the question is, this angle is given as 90. From here to here is given as 90, this length. From here to here is 1.83, from here to here 1.83 meter, from here to here 1.22, from here to here 1.22 meter. That is what it is given. Let this angle is alpha. Now let me show it in a different diagram, redrawn diagram. So you can compare it with the original diagram and find out the different angles. So the original diagram is redrawn here. So as you can see, I have taken this angle as alpha. The line of action of AS is passing through the point E, which is common to the line of action of the 50 kilonewton, and the line of action of the axial forces they meet at point E. This point is E. From here the reaction force has to pass to the same point, RA. Now, once that is understood, now let us explain the various angles. How, and this angle was given was alpha. 90 degree. This angle is given as 90 degree. This we have taken as alpha. So, now if you look at this dotted line and this one, this black line, they are parallel, and the bar itself is the transversal. So if this angle is alpha, then this angle will also be alpha. Again, this line is horizontal given, this dotted line is horizontal. This part from B to C, the part of the bar AB from B to C is the transversal for this line and this line, which are parallel to each other. Since this angle is alpha, therefore this angle is also alpha. So this is found out, this is found out, this we have taken. Now, then from here this is the perpendicular. So here this is 90. Now if you look at this angle is 90, this angle is alpha, this is 90 here. So the remaining angle in this triangle, I am moving my pen tip, this will be 90 minus alpha. Now this line is perpendicular to the bar. So this angle from here to here is 90. But this part from here to here is 90 minus alpha. Therefore we are left with, therefore this is alpha. This is alpha. Now if you look at the triangle EBA, from the tip of the triangle, this line is this dotted line is perpendicular to the bar AB at this point, means this angle is 90. Because this is the same line, this angle is given as 90. So here the total angle from here to here is 180. This is given as 90. So the remaining angle, this angle is 90. Now, so since the vertex of the triangle EBA, this line is perpendicular to the base, therefore the conclusion is side BE will be equal to the side EA. So since this angle is alpha, therefore this will also be alpha. This will also be alpha. Now then, how this angle is alpha. Now look, here this is 90, this is alpha, therefore this is your 90 minus alpha. So this is 90 minus alpha, so this will be 90 minus alpha being vertically opposite. And this y-axis at this point and this x-axis at this point, angle between the x-axis and y-axis at this point, this angle is 90. This we just explained how this is 90 minus alpha, so we are left with alpha. So this alpha is vertically opposite to this, so this will also be alpha. Now, then how this angle is 2 alpha, 2 times alpha. Look at this line and look at this line. Both are parallel and horizontal. and the line of action of RA passing from point A is pointing to this side. So this line of action is a transversal to these two parallel lines, this line and this line. The total angle here is alpha plus alpha, 2 alpha. This is 2 alpha. So this will be your 2 alpha. Once that is understood, now it is pretty simple. So I have explained all the angles. So C is the midpoint of bar AB, therefore angle BCD, and also given BCD is 90. BCD is 90, therefore BCE is also 90, because this is a straight line. At this point the total angle is 180, 90 plus 90, 180. This implies angle BCE is also 90. Therefore the triangle ABE is an isosceles triangle. Therefore the sides BE and AE are equal. BE and AE are equal. So the angles facing these sides must be equal. That is angle EAC, or you can say EAB, that is this angle alpha, must be equal to this angle EBC. Alright, so therefore alpha plus alpha 2 alpha, therefore this is also 2 alpha, because that is the corresponding angle. This is the transversal I just explained, and this line are parallel. This is the transversal. So since this total angle is alpha plus alpha, that is 2 alpha, therefore this will be also 2 alpha. Now, so RA makes, so what is the conclusion? RA, the reaction force from point A actually, but you can extend this RA parallel to itself like this, applying the principle of vectors. And if you draw x-axis and y-axis, RA makes angle 2 alpha with a negative x-axis. So RA makes 2 alpha with negative x-axis at point E. Now it is given BF is equal to FG. BF is equal to FG, each is equal to 1.22 meter. So in the triangle BFC, which is right angled here, if you take tan alpha, in BFC, if you take tan alpha, will be perpendicular over base, BF over CE, BF over CE, CF, BF over CF, sorry, BF over, this should be CF, and BF is known as is given as 1.22, CF is also given as 1.83, meter cancels, that is this much. So your alpha is equal to tan inverse of 1.22 over 1.83. I multiply this 100 with this 100, so this becomes 122 over 183. So alpha is tan inverse of this, that gives us 33.690067 degree. If you convert this in a scientific calculator to degree, minute and radian, this is your answer for alpha. Now since alpha is known and there are 3 concurrent forces at E, that is RA, the axial forces and the 50 kilonewton at point E. And at point E, there are 3 forces. Alpha is found out. This is one force, RA is one force, and S. The line of action of S, I have shifted here. The line of action of S, I have shifted here to this point. It is pointing to this side, and it is making alpha with the positive y-axis. Now the free body diagram is drawn, and then split the vectors into their rectangular components and solve. So the free body diagram at point E looks like this: 50 Newton along positive x-axis. This is your axial forces in the strut CD. This is your reaction force from the point of contact A. So let us apply sigma y is equal to 0. So if you drop a perpendicular from here, this length from here to here will be your RA times sine alpha. And here if you drop a perpendicular, this length will be your S times cos alpha. So S times cos alpha or A times sin alpha, they are already opposite to each other. So if their numerical values are equal, then sigma y will be 0. So RA sin 2 alpha is equal to S times cos alpha. So RA is equal to sin 2 alpha comes to the right hand side. So since we know sin 2 alpha will be 2 times sin alpha cos alpha, this cancels. So this becomes S times 1 over 2 sin alpha. So S is not known, we'll find it out. But alpha is known, so this value is found out. So this becomes 0.9013 times S, same as. Now then apply sigma x is equal to 0. Now how to apply sigma x is equal to 0? If you drop a perpendicular here, this length will be your RA times cos of 2 alpha. And if you drop a perpendicular from here, this length will be S times sin alpha. So this length will be S times sin alpha. And S times sin alpha, RA times cos times 2 alpha are pointing in the negative x-axis, and 50 kilonewton is along positive x-axis. So the sum of these two must be equal to 50 kilonewton for sigma x to be 0. So that is what I have done. So RA times cos 2 alpha is S times sin alpha. Now since we have found out RA in terms of S, so substitute that here. Substitute RA, that is this much. So cos 2 alpha remains like this. So S times sin alpha. So by doing so, what do we get? S is multiplied here, S is multiplied here. There are two different, this is one term, this is another term. So S is taken common. So within bracket we are left with this much, that is equal to 50 kilonewton. So this is multiplied, goes to the right hand side, will be divided. So is equal to this much. Now just use in a scientific calculator, putting this function, putting this fraction function, keep you will get a button like this. There will be something like this. You press it, then here you substitute value 50, then here you write these values together and press enter. It comes out to be 55.472 kilonewton. Now since S is found out and your RA, which I just explained as 0.9013 times S, put the value of S, so RA is found out. So RA is equal to 0.9013 times S, so put the value of S, so this comes out to be exactly 50 kilonewton. Now the question is, now we have to now that we have found out S is found out in kilonewton. Now the question is, what is the weight of the bar? Otherwise, if it doesn't have any weight, then how there is an axial force developed in the strut CD, right? So if you look at the original diagram, here, the diagram that I have redrawn here, the bar AB, this is the central point of the bar AB. From here, the weight must be acting vertically downward, W, and which component of S is along this line? Since this angle is alpha, so S cos alpha is to this side. So W is equal to your S times cos alpha, the weight of the bar. So S cos alpha, put the value of S, put the value of alpha, so this comes out to be 46.155 kilonewton is the weight of the bar. I hope the videos are enjoyable and you're able to make it out, because I'm explaining each part of it word by word. In case you feel comfortable, you can give a thumbs up and subscribe and pass on to your friends. Thank you.